Hi, Dick.
Hi, how are you?
Good. Yourself?
Well, thank you.
You coming out of this COVID okay, are you?
Yeah, I'm walking around. I keep a mask in my pocket for when it's appropriate, but
Yeah.
finding there are places where it's not needed. And
I
Monday evening, I had we had a dinner at the home of two fully vaccinated friends, and it was just like I remember as a kid.
it's quite something, isn't it?
Yeah,
Being
yeah,
able to get back together. You value things that you forgotten how much to value before.
yeah. You know what I find tricky? When something happened a while ago and you say, well, I don't know, maybe it was a year ago, you realize, no, it wasn't, because you have to add 1 year to everything. You didn't do anything last year.
That's right.
So
That's
if it
right.
seems like it was a year ago, no, it was 2 years ago. You have to add that. Yeah.
Yeah.
It's funky.
It really is. You're right.
Hi, Sherry. So I get we all need to kick in some money, I guess, right? Yeah,
There you go.
she's got the black glove.
Yep. Well,
Good evening, all. I might have to pop off here and there to attend to a senior dog, but I will always have my audio on and listening.
Senior
So-
dog. Is that what you said?
Yes.
Yeah. Okay, I understand.
So,
yep. So do I.
but I will still have the audio on and be able to keep current on the conversation.
Okay.
Good.
All right. Good. Good. Doug, hi. Max is there someplace?
Yeah.
Look at that. People are coming.
Yep.
Be a minute to unmute. Hello, everyone.
Hi, Doug.
Didn't realize this thing was on now.
It was funny he said about keeping his mask nearby when appropriate. My neighbors tell me I'm ugly enough. I should always be wearing a mask.
Well, I've been accused for the last 20 years of having a mask I can't take off. So what do you do?
It's a little bit difficult readjusting. You know, I walked into Damascotta Hardware and all the petitions were down and nobody was masking and all the floor stuff was gone. I said, wow, this is amazing.
New world.
Mm-hmm. About time.
Oh, wait, I can come and help. Okay. Okay. Mike, hi. One of the things that's been interesting about getting out and around is all the people that are more than just that tall, right? People got feet.
Yeah. Exactly. There you go.
Yeah, Shari, with your senior dog, I got an associate with an agency that her dog has diabetes. And so every day she gives or twice a day, I think, she gives the dog a shot. I thought, oh, that's interesting. It's all it needs. And it's not an old dog either. So.
At least now we'll really be able to appreciate the new sidewalk between town and Miles.
Ah, yes. Get out and walk. Yeah. Right.
I would strongly love to encourage, because this is being recorded, that people not discard their cigarette butts wherever they want.
No, I saved mine for in front of your house.
Okay,
Yeah, I don't just
but
indiscriminately. I wait till I'm by your house.
We want to put them where they make they provide the most benefit.
yeah. Somebody needs to invent a filter that at least is biodegradable or something, because I walk around Miles campus and there are so many cigarette butts on a non-smoking campus. And then also they blow into that brook and the ponds. So please encourage people not to litter their cigarette butts. So
Maybe
thank you.
maybe inventing a biodegradable filter isn't the answer. Maybe that's just succumbing to an issue.
Because I live right here at the blinking light near the Miles turnoff, and I see the people smoking, and right before they do the turn, they just go boop and toss their cigarette butt like the planet's an ashtray, and I just don't get it. So
Sale wouldn't go through.
a bit more soapbox there, but please, folks, police your cigarette butt.
So it's coming out of her commission.
There's the Congress.
It's 7 o'clock.
Thank you.
Someone.
Oh, yeah, just the partnership with them.
Okay, we're ready to start. And thank you all for coming on Zoom and in person. We appreciate you being here, and we appreciate the work that you've been doing right along. The only suggestion I have is next time, take the picture at high tide.
That's a good idea.
But we're here this evening to talk about the 30% plan for flood protection in the municipal parking lot. So with that, I'll ask you to introduce yourselves, please, particularly for the audience at home. The camera is right there looking in this direction. So after you introduce yourselves to the folks on Zoom and the camera, we can turn the camera around so the folks on Zoom will have benefit of the PowerPoint.
I can provide a bit of an introduction as well. This is Jan Wegman. He's the engineer, the lead engineer, project manager from Wright Pierce. And Mike Zarba is the project lead from Malone McBroom, currently known as SLR Consultants. So, and then you have our esteemed staff members here, George Parker and Bob Faunce helping along. So this is a project that Malone and McBroom and Wright Pierce have been working on for quite some time, since the time that you awarded the contract with them. You may recall that the proposals that we received from the various consultants were one large package that took us from preliminary design all the way up to construction bid documents. And after we reviewed the proposals and then following the board's preliminary approval of the Wright Pierce Malone McBroom proposal, we decided to split them because just from a common sense standpoint, we wouldn't know exactly what was going to be in the final design until we decided what would be in the preliminary design. So this presentation tonight and the report that follows will be the culmination of the 30% preliminary design. The Waterfront Committee has met a couple times, 3 times, with the consultants, and their perspectives may differ a bit from the staff, but as I explained previously, we needed to get the project within the bounds of the budget. And at this point, we're looking at a construction budget for the remaining parts of the project that doesn't include the contingency in construction management. We're looking at a budget of somewhere around 2.6 million, assuming that the Economic Development Administration will approve a change order for some of the changes we're talking about tonight. So with that, I'm going to, and just for the benefit of the Waterfront Committee and the others listening in, this is a Board of Selectmen workshop. So the discussion is going to be focused mainly on the board of discussion, but I know that Robin will allow a Q&A following the board discussion. So with that, I'm going to turn it over to Jan.
Thank you very much,
Turn the
Matt.
camera around, Matt. I need to turn the camera on.
I know.
Oh, yeah. There's they're just two logistical things is the camera, and those little discs are the microphones, so that they don't amplify anything here, but they allow people at home to
Oh, no,
hear.
that has to face the screen, so the folks on Zoom can see
Yeah.
what we're seeing.
Yeah.
Thank
And then
you.
everyone will get a copy of this later, but Jeff, could you move, one of those discs a little closer to Jan?
Thanks again, Matt, for that generous and nice introduction and set up for the project. Mike and I are here to kind of walk you through a little bit. We want to take a step back and just review some of the how the project came together and so forth, just so everybody's on the same page. So,
Can the folks here at home hear Jan okay?
We can now, we couldn't at the beginning.
okay.
Thanks.
So the overview of the project, the overall project for the parking lot area, if you will, the waterfront project, includes the public restroom, sewer improvements, an EV charging station, some flood protection, storm drainage improvements, parking lot resurfacing, pedestrian enhancement, and a waterfront park. And in terms of project funding, the funding for the project, as Matt kind of alluded to, we have a EDA, or the town has an EDA grant for about $3 million. The town's match is just over $1 million. There's additional town sources of $476,000. The Great Salt Bay Sanitary District is a participant in the sewer improvement project to $49,000. And Efficiency Maine had a grant of $2,500, bringing the total overall budget for the entire waterfront project to about $5.565 million. And when we look at waterfront project projected expenditures, we're looking at, right now, we have the, as you know, the restroom project is underway. The sewer improvement project is underway. And in terms of what those projects are projected to cost, we have those up on the screen: $734,000 for the restroom, $281,000 for the sewer improvements. The EV station's about $5,000. Legal and right-of-way is about $31,000. Engineering and design is about 401,000. Construction observation, which will happen at the, as part of EDA's requirements, is about 122,000 is the estimate. We have a contingency of about 350,000, and which leaves a construction budget available for the waterfront, the remaining waterfront work, the flood barriers and so forth, of about $2.637 million. And the waterfront project flood protection component, what I have up here is a map, is a flood map from FEMA showing where they have the flood, the current 100-year flood zone. And you can see that it occupies a good portion of the parking lot and comes up to the backs of several buildings. And some of the other issues that we need to deal with here are sea level rise and wave runup. There's quite a fetch to the south that would drive waves potentially up along with the high tide. And one of the other things that, well, one of the thoughts going into this is, wouldn't it be great if we could get the flood map revised based on our flood protection that we provide here with this project? That process through FEMA is known as a conditional letter of map revision, which is CLOMARS. They all, the federal government loves all the initials. So, and the initial step, which is the initial step to remove an area from the flood map, is you've got to design a project and take that design to FEMA, and FEMA's got to say, okay, that looks sound. Your engineering is sound. That will work if you implement it. And then it's followed up by a letter of map revision once you construct the project and you demonstrate that you did indeed follow the design and the area is deemed out of the flood zone.
Matt, this is Dick. Could I interrupt for a moment? That your screen is useless to us. It's just a big white blur. I don't know what to do about it, but your slide projection there is unseeable.
Is there a focus issue?
No, I don't know that you can solve that, given the optics.
Yeah, I agree.
Could you just
so you know, you're going to have to do some little stuff verbally, rather than just think that we see it. So
actually, it looks a lot better.
that's a little better.
That's actually.
And
Are the lights on in the room by chance?
right, I think when you turn the lights on, it actually helped.
Or no, I was going to say turn the lights off.
No, I think it's the other way around, but give it a try, please. That's better.
Yeah.
Yeah.
Thank you. Sorry to interrupt.
That is not as good.
Yep, we're good.
And the image that we have up here is an image that it's an aerial photograph of that downtown parking lot, and it has on it a number of elevation marks at all the doorway entries. And just so you get a sense, some of the doorways, some of the lower doorways are in the area of Damerscott Center and River Grill. Those are on the order of about elevation 7.7 to 7.9. 3 doorways there that are below 8 feet, 8 feet in elevation. And so what we did next is we looked at looking through the FEMA regulations, determining what the flood elevation is, and determining what our protection, our levee, which would be building, the wall can be considered a levee in this case, to protect that area. How tall does that have to meet, or does that need to be? And what we determined by looking at what the flood elevation is, the still water elevation for the 100-year flood is about 9.2. And then FEMA asks you to raise that up another foot. And then they ask you to do a number of other safety factors when you look at wave run up in that area, which adds additional height. And then you need to have a factor of safety on that as well. And ultimately, including sea level rise. So to the year 2050, we determined that the wall height, in order to protect that downtown area, would need to be 13.1 feet in elevation. The ground elevation around the perimeter of the parking lot is at elevation, approximately elevation 8. So this is 5 feet of wall that would have to be in place in order to protect that area, that would have to go from, from end to end. And in discussions with the town, we had a recent discussion with the town where we kind of looked at what that would entail. The town asked us, Matt asked us to look at a couple of different options. One was, let's look at what we can do to meet Clomar, meeting the 13.1 throughout that, to protect the entire parking lot and the buildings that are adjacent to the parking lot to that elevation. And then number two, look at what would a non-Clomar, so something that we couldn't get through FEMA to remove it from the map, but would be a reasonable wall height and setup from that. And what we looked at is we looked at a 11-foot high wall that would run from the Water Street entrance over to the corner of the parking lot by Alan McKinnon's building. So this would all be on town property versus taking a 13.1 foot high wall that meets Clomar would have to go all the way up to Main Street somehow to be able to, because that's where the elevation goes to 13. So for our option one, which is the Clomar option, the wall elevation would have to, would extend from Main Street. It would go on the west side of Allen's building, across Misery Gulch, the backside of Misery Gulch, and then around the perimeter of the parking lot by the boat launch and so forth, over to the Water Street driveway entrance until that entrance got up high enough. That particular option includes park improvements, includes a stormwater system enhancement. So one of the enhancement features there would be, we'd have to look at preventing water from the river entering back into the parking lot. So we'd have to put basically a gate valve or a flapper valve in those outlet pipes so that when the tide came up high enough, it wouldn't backfeed into the parking lot, which I understand it does now. We also looked at resurfacing the parking lot and pedestrian enhancement. And one of the other stormwater system enhancements, was we looked at, well, during this, what happens if you have a rainfall event in the parking lot and you only have so much volume in your stormwater system to store that water that comes into the parking lot. So we looked at how do we prevent the parking lot from flooding internally when you have a flood condition externally. And we looked at a host of different scenarios to try and come up with what's the 100-year or the 1% return interval for that particular scenario. And we looked at probability and ran a number of different models to see how big our storage would have to be in order to not flood any buildings internally during a flooding event on the river. And then our design option two, I'm just focusing on the west side here because that's really where the major change happens. It has all the same components as option one, but the wall height again is at 11 feet, not 13.1. And then on the west side, what we looked at is we looked at some temporary deployable walls or flood barrier type systems you could deploy in that area that to protect up to 11 feet of height. And we have some options there that we'll discuss later on as a as a stopgap measure. The wall itself would be designed so that in the future, you could raise it up to a higher elevation to 13.1. And we also looked at a 100-year sea level rise scenario that took us to over 14 feet high. So the very first thing that we looked at, well, we looked at several different wall options. When we started this project, our initial thought was, well, let's put a sheet pile wall up, we can clad it and so forth. When we ran those numbers initially, those numbers were coming in quite a bit higher than what we had for budget. So we went back and we looked at other alternatives, what we could do for a wall that would be less expensive and would be within our budget. And so we worked with Malone and McBroom's geotechnical engineer, Eric Teal, and I think he's also on the line in case we have questions for him. He's in the Zoom meeting, but we looked at a number of different foundation and wall systems. And Eric was able to work with a contractor who provided him with some information as well as some cost information on a rapid impact compaction process where you do some compaction at the surface that compacts and densifies the fill layer that's sitting on top of the clays enough to slow the permeability down so that when you get these surges in the tide, that you don't get that tidal influence doesn't come into the parking lot enough to really impact the overall structural characteristics of the parking lot and the wall. The sheet pile wall, as you can imagine, is a natural barrier, and that's one of the concerns in from a geotechnical perspective. If we need to have a wall that meets Clomar in the future, or the Lomar standards, you can't have a lot of movement of groundwater during these high tide events, which currently seems to occur in that fill layer that's above the clay and below the parking lot. And so what we did is we cost out these options, and it looked like the rapid impact compaction foundation method with a cast in place concrete wall on top appeared to be significantly cheaper per linear foot than the sheet pile wall system with a cast concrete wall on top. So I'll just go into just a little bit about what the foundation system is. These are some photos of the equipment and some of the procedures that are used. You can see that this equipment is usually done by specialty contractors that will come in and that have this equipment, and they come in and they'll densify the soil underneath the wall by these impacts that they do on this plate. Basically, it's a large plate. They create these holes and or these kind of depressions in between their locations that they do this. And so that densifies the soil enough to be able to, number one, support the wall, and number two, also slow the water down, the groundwater movement through that area. And the other thing with concrete walls, we had talked about potentially some form liners so you're not looking at just a straight concrete wall. This could be applied to either wall 13.1 feet or 11 feet high. But there's patterns you can put inside the forms when you cast these walls that look like stone, that look like some other pattern. There's a building I have a picture of that's up in Franklin that has it's an aquaculture building that has some fish cast into the side of it. You can do different things. So there's lots of different possibilities. Another component of the wall are the gates. We looked at a variety of different options: swing gates, sliding gates, automatically deployable gates that come up out of the ground based on water pressure, difference in water pressures. And then we also looked at stop log gates. These are by far the more economical, and they're very reliable. FEMA uses them in other, they're approved by FEMA in other locations. What it would mean is these are aluminum gates. They in between the wall openings that you have, you'd have to be able to, in advance of the storm, come in and set these aluminum planks in the openings and fasten them down so that they create a continuous watertight barrier around the site. So this would have to be done. We'd have to come up with a plan for FEMA, or the town would have to have a plan, and who would deploy these, where are they stored, that sort of stuff.
Can I ask a question? Would that also be the way you would close the boat ramp?
Yes. The boat ramp is one of the larger openings. You'd have to have a post in the center that would be removable posts that you could attach into this. Yeah. And you've got a few other gates, 2 other pedestrian gates into the park area through the wall, and the boat ramp are the 3 openings that we would look to be able to secure. For the temporary flood barriers, we looked at a whole host of possibilities. There are in the upper left is more of it's like a fabric type barrier that comes in a large roll. You could unroll it, and it's like a J laying on the long side with the open end facing the water, and the front lip is weighted so that stays down. When water comes up, it weights that area down, presses the membrane onto the ground, makes a seal there, and then the water fills up the bottom of the J, and that acts as your barrier. That's one way. There's other ways that are basically they're large tubes that would be filled with water in advance of the flood. Those take some time to deploy, but you could string that around the area that you need to protect. There's other ones that are they call porta dams. They're basically it's a truss type structure that you could set up, that you'd throw a membrane over that would come out in front of it a little bit, and that is used in a lot of different water or either diversion or flood protection type measures. These last 2 that I mentioned take a long time to deploy. As you can imagine, you'd have to get somebody there with a pump to fill up these water things. That first one can deploy very rapidly and easily, and we've included the cost for that in the cost estimates below when we get to those.
This is Mike Hurst. Can I ask a question about those membranes? Does that technology sounds very similar to oil booms, which are notoriously not very effective? Can you comment on this solution?
That particular solution, I mean, there are others that are similar, but these barriers, the one in the upper left, I know they do make them for chemical storage and chemical containment things. And they do provide protection. All these barriers, you would still have to have a sump on the inside that would keep up with some water intrusion that would get through these temporary barriers. It's not like a solid wall, but on the flip side, the flooding in this area from the river occurs during tidal events. So it's a limited time that you'd be dealing with this high water situation.
Question.
Yes.
To the south of us, they're having a lot of problems with flooding. Are any of these systems being used there, and how efficient are they?
And where are they used?
South of us.
South of us. Oh, okay.
New Orleans, Texas.
Yeah, that's a good question. If you and in doing research on these types of things, these types of barriers, the bladder barriers, they seem to be used fairly regularly, mostly along. I saw them mostly along river situations where you'd have some time to fill them up, and they'd be in place for a while. Now, river situations, flooding situations are a little bit different from what you have here, in that they tend to come up and stay there for a while, several days. And same thing with the porta dams. Those are used for a little bit longer term solutions. The deployable dams, I've in looking at doing the research there, it's really hard to say if they're used any longer term, but they are used in tidal situations. They're used in they're very deployable, very easily deployable and so forth. So from that perspective, thinking about, I think it would probably be a good fit for this particular location because it doesn't take a lot of time to do it. And again, your flooding situation is a very temporary one.
And we know when it's going to happen.
Right. So what I'll do next is get into some of the different components within the parking lot. As I mentioned before,
Excuse me.
yes.
Hi, on the inflatables, do they have what's their lifespan on that? And would they be deteriorating over time while they're in storage and not being used?
I'm sure they have a life. I didn't check out what the lifespan was, but they, I know they're used in reading the literature. They're used during several. They're not one use and throw away. They're used over and over again. But I couldn't comment on what their actual lifespan might be.
And how are they subject to? I'm sure they're very thick-skinned, but I'm concerned about punctures.
Yeah, they are fairly thick-skinned, and all of these systems can be deployed over some uneven terrain, if you will. So if you have like curbs or small, undulations in the ground, these things they'll mold to the ground itself.
Well, I definitely am curious about their longevity.
Yeah,
So-
I mean, that's certainly something we can investigate further and see.
Thank you.
So getting into the different other components of the overall project that we've got left to design, the stormwater management system, we have new catch basins and piping to put into the parking lot. One of the things we've discovered with the sewer project is that the existing catch basin system, storm drain system, is in very poor condition. So it's certainly appropriate to look at replacing it. We're looking at the tide flex valves on the outlets as they go into the river. So again, the river water won't back up into the system and flood the site from the interior. And in terms of what we needed to do to accommodate rainfall events during the tidal flooding events is to put in underground storage below the parking lot so that during the tidal flooding event, if you have rainwater gets collected by the storm drain system. It gets diverted into the underground storage system, and when your tide drops far enough, the water starts to drain out of that system. And what we looked at there was I've got some examples of what we were looking at. We were looking at an R tank, which is basically it's plastic crates that are assembled. They have plastic structures inside of them, but they're 95 to 98% open space. So most other systems might involve some chambers with a lot of rock around it. Rock is only 40%, has only a 40% porosity. So these systems offer a compact footprint, which is essential. We don't have a lot. I mean, we have a big parking lot, but there's a lot of other utilities in here. We have to kind of fit this storage in and around. And so we looked at that as a potential solution for the underground storage for the stormwater. And the system that we are looking at is about 38 by 228 and about not quite 3 feet tall. So obviously there'll have to be a large excavation. This system will have to go in place, and then the parking lot will have to be reconstructed over that portion of the storage area.
I got a question.
Yes.
So on a system of that size that you came up with, how much, and that's designed to handle the runoff of water during a storm, how did you arrive at that number?
Yeah, that's a good question. That, what we did is as we looked at, for instance, we took a rainfall event that would be happening, let's say a 10, 25, 50, and 100-year storm events. We looked at how much water that would generate over a particular period of time. We have hydrological models that model the rainfall event, and that we can also model the piping system, the storage system, and then we also can model the tidal outfall. And so what we did is we looked at these different storm events. We looked at the probability of a 100-year rainfall event happening on land at the same time as you've got this 100-year tide cycle occurring. And that happens to be, works out to about a 500-year event. If you combine those, if you use those two conditions, that would result in a much bigger storage system. So what we then did is we looked at the probability of what the sea level, what the river level is doing versus the probability of a 10, 20, 25-year storm. And we arrived at a combination of those things that would say this is the case that would happen once in 100 years. So from FEMA's perspective, they want you to look at what's the 100-year, what's the probability of something happening here 100, once in 100 years. And so that's we use that condition and design to that. And also the whole system's going to get surcharged, but the water level doesn't flood the buildings. So it doesn't get to that 7.7, which is the lowest door threshold that we have based on that modeling. So there's a lot of modeling that happened in order to determine that size. We looked at different size tanks, and depending upon how big a tank you use, the water level inside will go up and down based on the model, the storm events that you're using.
And that's our goal too, is to make sure everybody downtown gets out of that flood zone.
Right.
So that's why you have to arrive at something like this.
That's correct. That's what we did. In these systems, if we look at, well, let's say we go the path of the 11-foot wall, it doesn't meet Clomar, that area won't come out of the flood zone. But this system, if you build this system, you could extend that wall height and not have to go back and expand the storage here in order to meet that 100-year storm event.
This is also going to take care of the problem that we have on average twice a year with the king tides and the ponding in the lot. That's obviously a much more important issue for most of the businesses right now.
And then on the right, I've got what the Tide Flex inline valve, check valves look like. They're basically the rubber insert into the outlet pipe. And there's a membrane in there that picks up when the hydraulic pressure on the inside is higher than the hydraulic pressure on the outside. So it allows water to escape in that condition, and it closes once the water on the outside is at a higher elevation than the water on the inside. We also looked at some two pedestrian improvements. One is putting pavers in Taco Alley and painting a portion of the walkway down along the parking area. And then also looked at extending the sidewalk from the parking lot up to Water Street, about a 200-foot long sidewalk in that area. The parking lot itself, you may look at the slide and say, that looks like an odd shape. What we tried to do in all of our improvements is focus on what the town has control of. So we looked at the town property here, which is the parking lot, but it doesn't go up to the backs of some of the buildings. So from EDA's funding perspective, we need to demonstrate that we have the right title and interest to do the improvements that we say we're going to do. So, what we are proposing to do is to reclaim the parking lot and repave the parking lot and with 3 inches of new pavement. So we'd be reclaiming it, regrading it and repaving it. Now, there's going to be a large hole in the middle where the storage tank is, that area is going to, that's going to have to be, there won't be any reclaim on top of that, obviously, unless we reclaim it first, move that material, and then do the excavation and put the gravels on top again. The park improvements and living shoreline, these are this part of the project we carried in all of our estimates as well, where we looked at making improvements to the shoreline itself by introducing, redoing some of the riprap, to introduce some areas where we could do some plantings to create this living shoreline, and then have a fairly basic park on the surface. You'll see that a little bit later, and in some of our cost estimates, you may have noticed if you looked ahead on the cost estimates, that what we've done is done some basic park improvements, and then as alternates, we have a number of different options that you could select from, if funds are available, you could implement. So those are the different components, and what I've got now is a cost summary looking at wall option 1, which is the 13.1 foot high wall extended up to Main Street. And then option 2, which is the 11-foot high wall that extends just within the current town property. And I've included all the other pieces here. Really the only difference that we've changed is line number 5, which is flood walls and gates. That's really the only thing that changes between the two. And as we had mentioned, and as I've got noted at the bottom, our available funds are 2.639 million. And option 1, the cost for that cost option is $2.9 million. And it's for option 2, it's $2.487 million. So option 2 is still below what we have for available funds. Option 1 is going to be above it. And I wanted to at least present that to you, so you're aware of what those two different things represent. There may be other things that you want to take a look at, but the other things I just mentioned alternatives. Excuse me. I keep doing this. We did break out a number of different alternatives. One of the things we looked at was a form liner for the concrete, and that's about $100,000 per side of the wall to add that piece in. We looked at, earlier on in the project, we had looked at putting utilities underground. We've done an estimate where we just put the infrastructure in. We put the conduits, we put the large vaults, and we put all the conduits in the large vaults. Now that we have the parking lot torn up, because there's a significant cost associated with getting each and every one of those buildings hooked up or reconnected to new underground power. But we haven't included that in this, nor have we included actually installing the underground power. So, but we looked at that work is about $400,000. So in the future, if you wanted to implement the underground power, you'd have the infrastructure there. You'd still have some costs associated with running the wires and making the connections into the buildings, as well as transformers, things like that.
So just to emphasize that point, that price, the 400,000, just includes the vault and the vaults and the conduit. No,
The infrastructure,
yeah, the basic infrastructure, none of the
no wires.
yeah, wires. Right, exactly. So
That's
that's it.
potential, but it's not there yet. Right. And then we also looked at Taco Alley. Those are the two areas that we noted before. Taco Alley and the Water Street parking sidewalks, rather. We broke those out because we were asked, just asked to do that, just to make sure that everybody's aware of what those particular costs are. Under the park and living shoreline, there's several different amenities that we took out of the initial estimate that we had put together just to, as alternates. These, the base estimate that we've given you will get you the park area. It won't get you all the amenities. So we broke out a bunch of the amenities here. And again, from a logistics perspective, if you think about the park, that work is going to be a lot more difficult to do once you've got a wall in place. So doing the living shoreline and establishing the park area would be easier and more cost effective while you're doing that other work. So that's the end of my presentation. There's some more information for you in the estimates that we've put together, a little bit more detailed work. But we wanted to at least get this analysis in front of you so you can kind of see, what we're looking at in terms of wall heights, costs, things like that.
I know that all of the sea level rise estimates are estimates and there are different people doing the estimates, but it would be, I haven't heard any projections about how far to the future sea level heights, 11 feet versus 13.1 feet will protect us, protect the buildings that you're trying to protect. Have you worked at those projections at all?
Yeah, what we've done is we've looked at the state of Maine has done studies and makes recommendations outside of FEMA. They are, they've made projections on sea level rise. So they've got recommendations for people doing this type of work, that if you're looking to do a project, you want to have 1.5 feet above what the current levels are as a commit to manage level, and then up to or 3 or more feet above your current levels as a prepare to manage. So they make recommendations. It's not a specific number, and it's actually a range. I apologize. I don't know exactly what the range is, but we looked at the ranges, and 1.5 and 3 feet are potential. 1.5 would be the commit to manage, and then the 3 feet would be a potential prepare to manage in the future.
But my question was, do those numbers translate to any projected annual sea level rise that would therefore take us to a specific target date?
2050 was the target date that we looked at for this. We projected out to 2100 as well, but the numbers that Jan just mentioned are projected to the 2050 recommended times.
So I'm unclear about where 13.1 versus 11 is relative to those targets.
The 11 feet, again, the current flood elevation is 9.2. When you add in the wave run up, which is about 1.5 feet, and safety factors on top of that, that brings you up quite a bit. And I think what we had 1 foot, if you look at closely at this, and I don't know if you can see it well enough, but we had 1 foot above maximum base flood elevation, base flood run up on the wall. And when you have a wall, you have to account for additional water splash height, and so forth. We came up with an elevation of 12.6. That's before sea level rise. And that's what FEMA's minimum would be. But we brought it to 13.1 because we wanted to bring up we wanted to put the additional 1.5 feet above the base flood elevation to get us to that 13.1.
Mark has a question for you.
So the 13.1 will take us out 50 years.
Right.
No, that's not clear.
Well, no, it'll take us to 2050, at least according to the state. Yes.
Okay. And then that height will also give everybody the tax benefit on their insurance, not tax,
No.
flood insurance for everybody downtown. That would take care of that.
Yes.
That's 13.1. Yes.
13.1.
The Lomar and the Lomar that would be.
Please turn your music off.
I'm sorry, I can't turn the music off, but just a second. Okay, just a second. I want to talk about the mathematics here because we're being ingenuous and we're using numbers decided by politicians, and the glaciers in our.
Josh, if you could wait a minute, Mark was asking a question, and the workshop is, and I appreciate
You're
your
right.
interest and concern, but this is for the selectmen that haven't heard any of this before. because
Okay, Robin, I will wait. I just know that the mathematics that's being answered doesn't answer the question. I'll shut up.
Okay, if Mark, if you want to finish your question, and maybe that'll help clarify.
Well, I guess what I'm getting at is I don't want to see us cut ourselves short because of X amount of dollars. And I do know that a perfect example is back in 1998 when we built onto the school, it was $3 million. Today, it would be closer to $9 million 20 years later or 20 plus. So I think that we're selling ourselves short if we're trying to squeeze the dollars too much when we should be looking at the long-term benefit cost-wise and taking care of everybody downtown.
Well, if we go with option one, which is the 13.1 wall height, we need to come up with another $300,000.
Yeah, the figure we looked at earlier was 400,000, but it looks like from this latest, we're closer to 300,000. But the other factor we should take into account, and the board should take into account, is the wall height above the ground.
Right.
So the 13.1 is approximately 5 feet above the ground, and the 11 feet, of course, would be with 3 feet. So the 3 feet wall would be just above where the fence is now, essentially.
Got a guardrail that runs along the edge.
Guardrail, yeah. So I think that visual, that aesthetic impact has to be taken into account in addition to, having to find another 300 to 400,000.
My other question would be is from the Biden administration, who has signed over some money for the hurricane FEMA monies. Is there any money available in our project, even though it's been going on, that we could actually tap into for additional revenue?
There are no guarantees.
Yeah, I mean,
Possible. We haven't yet fully explored other funding opportunities yet. The other thing that would have to be secured is a right of some sort of an easement or something else to go to finish the wall up to Main Street. Because currently, we've got it on paper. We don't have a right in place to do that. So
That would be by Narragansett or the butcher shop now.
We're still in a landings property and.
Yeah.
we either have to get an easement that's acceptable to the Economic Development Administration, or they won't allow us to use grant money on private property. As far as additional grant money goes, so I did ask EDA whether they would approve either more money or the 11-foot option, and the answer, not surprisingly, was unclear. They said that if we want to go with the 11-foot option that protects our businesses but does not provide any assurance of a clomer, if we want to do that, we got to go for a change order. Just because our grant application inferred that we'd be pulling these businesses out of the floodplain. However, if we want to go for additional money for the 13.1 option, we know we've got to find another 400,000.
Are
So-
these in today's dollars? You know, the price of lumber has gone up 300% in the last
Maybe not
year.
next week's.
Yeah, you know, when you're looking at these numbers, how real are they? You know, based on this project that's going to take, you know, a ways to go, and you know, how real are they?
That's a very good point. I mean, we've tried to be conservative on our numbers, and they are from what we've known recently. But we're in a volatile situation right now. You know, concrete, steel, which
Everything.
Yeah.
a lot of what we have here, those types of materials are very volatile right now.
And I know there's a contingency in here of 35,000+. You know,
That's
there-
not,
300.
yeah, of three, but you know, that can
We don't
go.
want to use that up now, no.
You know, can I ask another question? And I know that you've done this, but just for me. When I'm looking where you have this underground tank and you're telling me it's plastic and it's all right under where all the cars are going to park. And then trucks, heavy trucks are going to be driving down the driveway there, 18-wheelers. Is this really designed to be put under a parking lot?
It is. Yeah.
Okay, it's not going to cave in?
these gentlemen have a problem.
Home structure.
Yeah, it's like a honeycomb, or it's got other structures inside. It's all, you know, plastic.
Okay.
Crates.
Yes, sir.
We just wanted to let you folks know that the Y is closing in about 10 minutes. We just want to give you guys a little heads up.
Thank
I
you.
don't know how late you guys are planning on being here. I just want to check in real quick.
Okay, we'll talk fast.
So Bob, did you have a point?
Yeah, I want to make a couple of comments. The numbers, the 13.1 feet, those are recommendations from a quite a prestigious group of in-state scientists from the University of Maine and others. That recommendation to 2050 is not a political recommendation. It was included in the governor's climate plan, but only because it was a recommendation by those folks. So I think that's a solid recommendation for 2050. We have two alternatives. One is to go to 11 feet. The other one is to go to 13.1 feet. Our concern is we didn't have the money to go to 13.1 feet. That's why we suggested two options. The option two being 11 feet. But we asked the engineers to make sure that wall is designed so that it can be extended structurally. It's got the ability to be extended in the future. If we come up with the extra money, that would be fine. But if we don't, we haven't precluded anything. So just want to make sure you understood that. Second thing about the concrete forms, that's an additional $200,000. And we think it's $100,000 on each side. We think that's a terrific idea, but it's $200,000. Perhaps that could be subject to local fundraising, the design of those forms, whatever images that are on could be a local contest. Certainly Damascotta has got more artists per capita than probably any other area in the state. And perhaps that's a contest to, or each separate section of that wall could be a different image. So I just want to make sure it was understood that those recommendations on heights, that didn't come from the governor or from some representative. It came from a scholarly group who had the knowledge and wherewithal to make them.
Thank you. Other questions about any of this, any and all?
All right now.
So we're not sure, Matt, even if we go with the 11-foot option, if the EDA grant you have to go back and reapply.
I have to. I wanted some, at least preliminary direction from this board, and then I'll pursue that further. Yeah.
So our options really are the 11 foot wall
Right.
with the possibility that it may not be approved, or the 13-foot wall that we don't have the money for.
Yeah,
You know, so, and it could be that if the other wall, if the 11-foot wall is not, if we say, well, let's go with the 11-foot wall because we know it can be built to 13 feet when we get additional money over time. And even if it's just plain old concrete until we have a fundraising effort, you know, to have it nicely decorated and what have you. If we go with the 11-foot, because we know it can be increased if we get the money. And maybe that, if that's what the board decides, maybe that's the argument, justification, whatever, if you will, with the funders, that we're trying to stay within the money.
yeah, and they realize
You
that.
know, we don't have the money.
yeah.
And then they say, well, gee, we'll give you another $300,000.
Yeah.
And we say, perfect, we'll do the 13-foot wall.
You know, at one point, we were looking at, before we, you know, had the expensive part of the study done, we were, in our preliminary study, we were looking at raising the parking lot 2 feet.
Right.
So a 5-foot wall wouldn't have looked that great, but now when we had Wright Pierce do the initial analysis, they said there's no way you could raise that parking lot with so much asphalt because the subsurface won't support it.
Except that now you're putting this big plastic thing in the middle of the parking lot, so that could be used to raise it.
Yeah, well, there are other considerations. For instance, there's a couple of sewer lines that run along along that edge of the parking lot, that if you were to raise that edge of the parking lot, it could depress, you know, it could settle over time, and that could cause problems.
You have an
issues.
unfortunate layer of clay
Other problems.
Yeah.
Yeah.
underlying all of that parking lot, and it's subject to consolidation and differential settlement. And there's a big concern about the existing utilities and the longevity of a project that, you know, you're gonna spend plus or minus $3 million on. You know, we needed to make sure it lasts and it doesn't fail on you. So, yeah, unfortunately, you have some soil conditions that don't allow for some of the options that Matt talked about.
Is there a possibility that you could increase the height of the wall at some point with clear plexiglass or something? So if you're in the parking lot, you can see through it. You know, you're not looking at, I'm only 5'4", so, you know, it's going to be a wall for me, you know, so you're not going to, it'll have more of an aesthetic if it's, you know, 4 feet above the ground, that's cement, concrete, whatever. And then the next 3 feet, you can see through. Is that a possibility for the future?
I mean, there's a whole host of options to extend the wall height. You could do it, you know, I would recommend that you do it in a way that's more permanent, so you don't have to employ, you know, boards or whatever you want to do to raise the wall height when the storm's coming, because that's a 500-foot long wall, or 700 feet if you go the entire length. You could do some see-through options, but I think that would be a maintenance issue because of the salt environment and everything else, the splash, you know, it's still quite a height to get to, but there may be times when it would become an issue.
You're gonna have scratching. Discoloring.
Okay.
Yeah, the board can't take formal action tonight anyway.
Okay.
And I think you've heard, you know, the information, the basic information from Wright Pierce, SRL, LR. Yeah. So do you want to just continue this conversation
Yeah.
at some other point? Gives folks a time to think about it more, and same with the Waterfront Committee.
Yeah, I appreciate
Yeah.
all of this. This is really helpful.
Just wanted to mention real quick that we're talking about $300,000 now. But 10 years down the road, 5 years down the road, it's not going to be $300,000 to add on.
That's
true. So that investment.
Doug Morton's had his hand up for a long time. Are you guys going to let him?
Okay, Doug, you have a question?
Well, I don't really want to impose, but I just wanted to I hope I'm going to help clarify things. If the focus stays on the 11-foot wall with the ability to raise it as necessary as time requires, then it seems to me, at least, that seems to be the obvious solution, because you don't want this 13-foot wall until you need it, because you're just causing an obstruction of view that's not necessary for the next, who knows, 15, 20 years before it's absolutely needed. So go with the 11 with the design to increase as necessary when time demands. I think OSHA would be happy with that, but what do I know? And it's going to definitely save money. My other concern, however, is what is the steady state water level? Say, this is impossible to answer, but the question is, let's say, when in history will the water be above the boat ramp 4 hours a day, twice a day, on a regular basis, not a storm surge? Just at what point in time? If that's 15 years from now, when we can expect the average tide to be above the boat ramp, that means we're restricting the boat ramp with whatever means you use twice a day. So that's something that has to be factored in here, is the significance of the access of that boat ramp. Nobody's talking about that at all. We're just assuming when the tide gets high enough, we're going to block it off. I'm not sure that that's the right answer, but I don't know what the other answer would be.
Thank you, Doug.
May I make a comment, Robin?
Yeah, go ahead, Haas. Quickly, because they're going to kick us out of here.
Okay. Here, my concern, I want to respond to Mark's earlier concern about what can we predict for at the 50-year and 30 years from now in 2050. The problem is this: the scientists that are really looking at sea rise carefully are scared shitless, pardon my English, by how fast the glaciers are melting over Antarctica and over Greenland. Now, the basic mathematics is this: if those glaciers were to all disappear, the sea level would rise 200 feet. So only 10% of them have to disappear for our sea level to be 20 feet higher than it is now. So in terms of Mark's concern about what do we do, spend a little bit now and save later, I think we need to look very closely at how long we want that downtown to be viable, and the fact that we really do not know how fast sea level is going to rise because of how fast those glaciers are melting. Remember, only 1/10 of them will raise our sea level 20 feet.
Okay, thank you. All right. Does the board have any further questions?
No.
Since we have our experts here.
This moment.
Not at this
Okay.
moment.
Well, thank you for everything you've done. And also, thanks to the committee that's been working, to make it all work for us. We really appreciate your time and doing this. And for your contributions. I was down looking at the restrooms yesterday. They look great.
So close.
Thank you. Thank you.
Close our workshop. And thank you for those people on Zoom that have Zoomed in. We appreciate you being here. And the computer is way at the other end of the room, so I didn't see that anybody had their hand up. So my apologies for that.
We couldn't do the Google thing. Yeah, unfortunately.
Okay.
Thank you all.
So, thank you. Everybody get your little